Students, this is note number 1 for chapter 5, light energy. We'll be learning about light energy now and how light helps us to see and the refraction of light. Let us understand some points about light. Now, we know that light is a form of energy and this produces the sensation of vision in our eyes. That means light helps us to see things and it makes us to see various things present in our surroundings. If there is no light, we cannot see anything. So we understand that light is a form of energy that helps us to see things around us. And when light falls on an object, some part of light gets reflected back to our eyes, and then only we are able to see an object because the light is being reflected from the object. So if the light is not reflected from the object, we will not be able to see it. So this second point, we understand that when the light falls on an object, some part of the light is reflected back to our eyes, and that is why we are able to see it, like you see in the picture below. When the light is falling on the surface, we can see many things, right? We can see the landscape, we can see some bushes, a rock, we can see the sky, we can see the clouds. It is only because the light is falling on it and the light is being reflected from these objects, and that's why we are able to see. But in the dark night, we won't be able to see these things, even if these things are present, but we will not be able to see these things. A very important part about light, that's what we'll be studying now, refraction of light. Now here you see a diagram that will explain to us the refraction of light. Now this rectangular slab is a glass slab, okay, that is made up of glass. Now it is marked as PQRS. And the first point I want you to understand here is this dotted line that you see. There are two dotted lines present here. Now these dotted lines are drawn perpendicular to the reflecting surface, okay, or the surface between the two optical mediums. So the normal is a dotted line that is drawn perpendicular. Perpendicular refers that it should form 90 degrees to the refracting surface. Okay, so here we have two normals that you can see here. And the next point that I want you to understand is we all know that light travels in a straight path, right? Light travels in a straight path. So that ray of light that strikes the surface separating the two optical medias. Now here there are two different medias. One is the air, which is outside the glass. The other one is the glass. And then we have air, because we are going to see what happens to the ray of light when it moves out from the glass to air. Another thing I want you to remember is that air is a rarer medium. Glass is a denser medium. Okay, so you keep these few things in your mind. Now you notice here that the incident ray, or that ray that strikes the surface separating the two optical medias, which are the two optical medias, air and glass. So that ray is termed as incident ray. Okay, and here you notice that there is an angle formed. Now this angle is formed between the normal and the incident ray, and the angle that is formed between the normal and the incident ray is known as angle of incidence. Okay, that is known as angle of incidence. Now what happens to the light ray when it passes from the rarer medium to denser medium, that means from air to glass? You notice here that the light bends, right? The light ray is not straight as the incident ray inside the glass, but when it moves from the rarer medium to denser medium, that means from air to glass, you notice that the light ray bends. Okay, and this bending of light when it is moving from a rarer medium to denser medium is the refracted ray. Now refracted ray is also termed as transmitted ray. Okay, then we can also define a refracted ray as the light that is transmitted through the surface. Okay, we can also define refracted ray as the light that is transmitted through the surface. You notice here that this light is transmitted through the surface, right? This is the refracting surface. So the light that is transmitted through the surface is known as the refracted ray. And even here there is an angle formed, right? There is an angle formed between the normal and the refracted ray. And the angle that is formed between the normal and the refracted ray is known as angle of refraction. Okay, the angle that you see here, which is formed between the normal and the refracted ray, this is known as angle of refraction. All right, now this light ray passes through the glass slab, right? This is a refracted ray. Now when it is moving in the glass slab, that is a refracted ray. It will move in one straight path because we know that light travels in a straight path. But here you notice that when light ray moves out of the glass slab, glass is a denser medium, air is a rarer medium. So here we are seeing that the light ray is passing or moving from a denser medium to rarer medium. What happens to the light ray? It bends again. Okay, it bends again, and this light ray moving from the denser medium to rarer medium is termed as the emergent ray. Now this ray of light that emerges from the medium after refraction is emergent ray. Okay, so emergent ray is that ray that emerges, that moves out from a medium after refraction. This is emergent ray. And here you notice that an angle is formed here, the angle between the normal and the emergent ray, and this is known as angle of emergence, and this is denoted by the symbol or by the letter small e. And refracted ray is denoted by the letter small letter r. Okay, and the incident ray is symbolized by small lettered I. So this is the ray diagram to show the refraction of light. Now let us understand the causes of refraction. What are the causes of refraction? The first cause we'll see here is, we already have learned that refraction occurs as light passes across the boundary between the two media. That means refraction will take place when light passes between two medias. In the previous illustration, we saw that the light is passing from the rarer medium to denser, air to glass, and again from glass to air. Then only refraction will take place. The second cause of refraction is that the transmission of light across a boundary between two media is accompanied by a change in both speed and wavelength of the wave. So the refraction or transmission of light, it is accompanied by change in speed of light and wavelength of the light. Okay, the light ray. We will be understanding it more in the future. Okay, but still I would like to tell you that the speed of light in denser medium is less compared to the speed of light in rarer medium. The next cause of refraction is that the light wave not only changes directions at the boundary, it also speeds up or slows down and transforms into a wave with a larger or a shorter wavelength. Okay, so it's not only that the light wave changes directions at a boundary, that means it bends. But the light ray also either speeds up or slows down. Like I was telling that when it moves in a rarer medium, it is faster. When it moves to the denser medium, it becomes slower and also transforms into a wave with a larger or a shorter wavelength. So even the wavelength of light in rarer medium will be different than in denser medium. The next cause is as long as the light wave changes speed and approaches the boundary at an angle, refraction takes place. So till the time light wave or light rays changes speed and reaches the boundary at an angle and forms an angle when it passes through the refracting surface, refraction will be observed. So whenever the light wave changes speed and approaches the boundary at an angle, refraction takes place. Now let us understand why a change in speed of light causes refraction of light. Now this is because whenever light changes, whenever light changes media, its speed also changes. So whenever light changes the media, I was telling you rarer medium and denser medium. Air is rarer, glass is denser. And when we compare water and glass, glass is still denser and water is okay. And if we compare air and water, air is rarer and water is denser. So this is because whenever light changes media, its speed changes with respect to that media, and that causes bending of light. Either it will bend towards the normal or away from the normal. Okay, we'll be understanding this in the next point. So why a change in speed of light causes refraction? Because when the light moves in a rarer medium, the speed of light is more. And when the light moves from the rarer medium to denser medium, the speed of light becomes less. And that is the reason why it bends. And it bends towards the normal. So it will either bend toward the normal or away from the normal, only in consideration when the light ray is moving from a rarer medium to denser or denser medium to rarer medium. Let us understand the rules of refraction. The rules of refraction. In the diagram, you would see that when a ray of light goes from a rarer medium to a denser medium, it bends towards the normal, right? It bends towards the normal. If this light ray would have not bent, if this incident ray would have not bent, it would have gone straight like this. But you notice here that the refracted ray bends towards the normal. So the first rule is when a ray of light goes from rarer medium to denser medium, it bends towards the normal. The second rule of refraction is that when a ray of light bends from a denser medium, to a rarer medium, you notice here that the ray of light is moving away from the normal, right? It is moving away from the normal. So this is the second rule of refraction. You have to remember that when ray of light goes from a denser medium to a rarer medium, it bends away from the normal. So these are the two rules of refraction. I hope you have understood till here. Keep learning and keep studying well.